How vitamin B3 supports cellular repair is becoming one of the most interesting threads in modern aging research, and recent human studies are painting a far more optimistic picture than many people expected. When scientists talk about vitamin B3 in this context, they usually mean niacin and its derivatives, nicotinamide, nicotinic acid, and the increasingly studied NAD precursors like NMN and NR. All of these compounds feed into the body's capacity to maintain DNA integrity, sustain mitochondrial function, and manage inflammation, which are three of the most central pillars of healthy aging. And although earlier discussions often focused on mechanistic lab results, the newer wave of evidence from human trials is giving stronger reassurance that these pathways matter in real, everyday physiology. Vitamin B3's role in DNA repair is especially compelling. NAD, which depends heavily on adequate B3 intake, acts as a cofactor for the enzymes that fix damaged DNA strands, enzymes like PERP and sirtuins. As we age, NAD levels naturally decline, and this decline is linked with slower repair of the constant microdamage that accumulates from normal metabolic activity, UV exposure, or oxidative stress. Several small human studies show that replenishing vitamin B3 derivatives can raise NAD levels modestly but meaningfully, with participants demonstrating improved markers of DNA repair activity. These aren't miracle changes, but they're enough to suggest that the body retains a remarkable ability to restore its internal maintenance systems when it's given the right nutritional support. What's equally encouraging is the anti-inflammatory effect seen in trials. Chronic, low-grade inflammation, sometimes called inflammaging, is one of the quiet forces that accelerates everything from joint deterioration to metabolic slowdown. Vitamin B3 intersects with this pathway by modulating immune cell behavior and supporting the enzymes that control inflammatory signaling. Some human studies observe reduced markers like CRP or pro-inflammatory cytokines after supplementation with NAD precursors, and participants frequently report subjective improvements in energy, skin health, or exercise recovery. While self-reported changes aren't hard clinical endpoints, they add weight to the idea that cellular-level benefits can translate into how people feel. Mitochondrial health is the third major area where vitamin B3 shows promising results. Mitochondria are hungry for NAD, and when they don't have enough, energy production becomes sluggish and cells drift toward dysfunction. Research in older adults has shown that boosting B3 derivatives can slightly increase mitochondrial respiration and enhance the cell's ability to generate ATP. These effects aren't dramatic, but their consistency across different studies, often involving older participants or those with mild metabolic impairment, makes them noteworthy. They suggest that even late in life, the energy-producing machinery inside cells is capable of revving back up when given the right biochemical tools. One of the more positive, forward-looking insights from these studies is that vitamin B3 interventions appear relatively safe and accessible. The doses used in human trials are typically within ranges achievable through diet or modest supplementation. Foods like poultry, fish, peanuts, whole grains, and mushrooms naturally provide niacin, and the body can also convert tryptophan into B3, offering a second nutritional pathway. This means people don't need exotic or extreme regimens to support these cellular processes, they just need consistent, adequate intake. Even the more specialized NAD precursors show a strong safety profile, with the main caution being the flushing reaction associated with high-dose niacin, a harmless but unpleasant effect that many newer forms avoid. Looking at the broader picture, the emerging evidence paints vitamin B3 not as an anti-aging miracle, but as a quietly powerful supportive nutrient, one that helps the body maintain functions it is inherently designed to manage. The ability to repair DNA, calm inflammation, and sustain mitochondrial output are all natural processes that tend to falter with age, but B3 seems to help hold those systems together. What makes the research hopeful is that these benefits appear achievable for most people, without extreme interventions or unrealistic expectations. The message is less about reversing aging and more about giving the body the biological resources it needs to stay resilient as the years accumulate. In a field often filled with hype and conflicting claims, vitamin B3 stands out because the mechanistic understanding aligns with real human data and the practical implications are genuinely positive. While research continues to evolve, the current trajectory suggests that maintaining robust B3 status through diet, lifestyle, and carefully chosen supplementation may be one of the more grounded, evidence-supported steps for supporting long-term cellular health.